Okay, so apologies, we've got a sort of a longer video coming up here. So we're going to do the derivatives of inverse trig functions, and at the end of the day, we're going to show you the proofs, but you just have to, at the end of the day, know how to use them. Okay, so we're going to start off with the first one, which is y equals sine minus 1x. Okay, and so to make x a subject, we take sine of both sides, so we've got x equals sine y, so that's straightforward. So the derivative with respect to y would be sine turns into cos, so the derivative is cos y, and then I flip dy dx upside down, so I flip cos y upside down, and then you've got to remember over here that sine squared plus cos squared equals 1, so cos squared equals 1 minus sine squared, so cos y equals 1 minus sine squared y. So when I've got this cos y, I've got the square root of 1 minus sine squared y, but sine squared y, well, sine y is x, so sine squared is x squared. Okay, so this means that if you have a function that is an inverse sine function, if you have a function that's inverse sine, then its derivative will be 1 over root 1 minus x squared, which is easy because any of the sub values in. Okay, copy that if you want to, but you, at the end of the day, you just have to know that block of green. Okay, come across when you're ready. Okay, so I'm not going to do the proof for cos, but you can actually show with the same proof that the derivative is a minus 1 over root 1 minus x squared, and again, that's all you have to know at the end of the day, so copy that and come across when you're ready. Okay, we're going to do the proof for tan minus 1x, okay, just so you know it. At the end of the day, you just have to know that red block. So let's start off with let the function equal tan minus 1x. To make x a subject, we take tan of both sides, so I've got tan y. So the derivative with respect, so d dy of x equals d dy of tan y, and the derivative of tan y is sec squared y. And from our sine squared plus cos squared equals 1 basic formula, sec squared equals 1 plus tan squared. But then tan is x, so tan squared is x squared. So dx dy equals 1 plus x squared. So if I turn dx dy upside down to dy dx, I turn 1 plus x squared upside down into 1 plus 1 over x squared. 1 over 1 plus x squared. So that's what you have to know. You don't have to know the proof. So copy that, come across. Now, we don't always have simple functions, so there's these derivations of these fractions which turn into these, and I'm going to do the proof on the next page, but basically if you just copy that down, excuse me, that's what we're going to be using, but I will do the proofs for sine and I'll do the proof for tan on the next page. So copy that and come across when you're ready. Okay, so here's the proof for the general case. So y equals sine minus 1xa, because that's what I want to do. So if I make x on a the subject, I take sine of both sides. Now, if the angle is y in this corner here, sine is opposite, that's the opposite, and that's the hypotenuse. And then using Pythagoras, you get this side, the missing side, equals root a squared minus x squared. Okay, so now what we do is come back up to here. So x on a equals sine y, so if I take a across, I have a sine y. So the derivative dy of x equals dy of that mess, and a is just a constant, and sine y, when you take the derivative with respect to y, sine y turns into cos y. Now what we do is we now look at this triangle over here. So there's y, so the cos is adjacent over hypotenuse a, and then the a's cancel out, so you're left with root a squared minus x squared, and then I just flip that upside down to that, so I flip that upside down to that. So if the function started as a fraction, you end up with that one. Okay, so again, you don't have to copy the proof down, but I just showed it to you anyway. Okay, let's look at the proof for tan. Okay, so the proof for tan. So again, the function is tan minus 1. Make x on a the subject by taking tan of both sides. So if I put y in that corner there, this is the opposite and this is the adjacent. So opposite, adjacent, and then using Pythagoras, you get that value there. Okay, so then I go x equals a tan y by getting the a off the bottom to there. And then so the derivative with respect to y of x equals the derivative with respect to y of that mess. A is a constant. Tan y turns into sec squared y. And sec, the third letter, is c. So sec squared is 1 over cos squared. So we end up with that. And then we look at the triangle over here. And cos is adjacent. Okay, there's the adjacent. And over hypotenuse. But it says squared. So that's where that squared sign comes in. Over there. And then a squared is a squared. And then when you square a square root, you get that. And then instead of dividing by a fraction, we multiply by the reciprocal, and then that a kills one of the a's, and then the final step is dx dy flips upside down to dy dx, so we just flip that upside down to there. So that's the proof. Okay, so you don't need to know the proof, but there is a proof. Okay, let's have a look at some worked examples. Okay, so the first one we're going to do is sine minus 1x. So I'm going to show you two ways, and then you've got to choose which way is best. Okay, so if we're looking for the model of x on a, if that number is 4, then a must be a quarter. Okay, and so the derivative, so I'm going to show you two ways and then you pick which way you like. So the derivative will be 1 over square root a squared minus x squared. Now that's pretty ugly, lots of fractions. So we've got 1 over square root. So that number is going to be 16. So if I'm going to combine these two, the lowest common denominator is going to be 16. So that'll be 1 squared is 1. And then we've cross multiplied the 16 to there. Right. And then we've got 1 over the square root of 1 minus 16 x squared, which you cannot square root because there's a plus sign in between, a minus sign in between. But the square root of 16 equals 4. And so when we multiply, this is divide by a fraction, so we multiply by the reciprocal. So what happens is that 4 comes up to the top. And so our final answer is that. Now that's one method, but there's another method as well. So you can choose which method you want to use. So we say, well, that's a function. So let's make a substitution. So let u equal 4x. And so du dx equals 4. So the function becomes sine minus 1u rather than sine minus 1 4x. And so we've got dy dx equals dy du times du dx, the chain rule. Okay. You should have had that a few times now, the chain rules. The du's cancel out, so you've still got your dy dx. So dy du is this function with respect to u. So it's 1 over square root 1 minus u squared, okay, times du dx, which is 4. So the 4 comes to the top, and then 1 minus, and then go u back to 4x. So 4x squared is 16x squared. So you choose which way. I like the substitution method, but you don't have to if you don't want to. But I do like this method. Okay, copy that, come across. Come on. Okay, so we've got another one. So I'm going to do the substitution, just go straight to it. So let u equal x minus 2 over 3. So du dx equals a third. Okay, so that's derivatives 1/3. Excuse me. So the function is tan minus 1u now, and dy dx equals dy du times du dx, the chain rule. And so the function for that one is 1 over 1 plus u squared times du dx, which is a third, and equals, excuse me, 1 over 1 plus x minus 2 over 3 squared, excuse me, times a third. So we're going to do a bit of tidying up. 1 over 1 plus x squared minus 4x plus 4 over 9 times a third equals, this fraction here has to be simplified by multiplying by 9. So we've got 1 over 9 plus x squared minus 4x plus 4. Now that divide 9 will come up to the top, and we've still got times a third, and finally 3 into 9 goes 3 times, and then x squared minus 4x plus 13. Okay, so I think that method might be better. You can certainly, yeah, I'll do it the other way as well, just so you know there is another way. Y equals tan minus 1 x minus 2 over 3. So dy dx equals a over a squared plus x squared. Okay, so this is in the form of x on a. So we've got, okay, that's the 3, so that goes upstairs. Then square that, so we've got 3 squared plus, now that's okay because it's just a single function. Okay, so we've got 3 over 9 plus x squared minus 4x plus 4. So you do get the answer a little bit quicker, but you just have to be wary that that function was like a linear function. But at the end of the day, practice makes perfect. See how you go. Thanks, bye.